Hello, everyone. This is the lecture for section 2.1 to 2.3 for our Math 210S course, linear functions, the graphs, and modeling. Okay, so in this section, we're going to cover the very first of our particular functions that we're going to be playing around with for the entirety of this course. It's the simplest types of functions that you can think of. It's linear functions. They're lines. Okay, so we're going to take a look at the anatomy, what we would expect to see on a graph, what we can interpret from each portion of it. Okay, and then once we get to calculus, it'll be much easier for us to sort of manipulate the stuff when we're actually looking at the calculus portions, not just the algebra portions. Okay, so the first thing I want to do, okay, is I want to define what a linear function is. Okay, so a linear function. So at this point, we know what a function is, right? A linear one, okay, is a graph, right? Is a function whose graph is a line. That's simple, okay? In order to make a line, right, the linear function has to have this kind of formula right here. You might remember it from high school is this right here, the y equals mx plus b. Either which way you remember it is fine with me, okay? A linear function, right, has two parts, the m and the b. The b is what we call the initial or the starting value, right? And the m is what we call the rate of change, okay? And it is a constant rate of change, okay? Or the other word that's used sort of intermittently between the two is the slope of a function, okay? And the other way you can remember this is this, that the y-intercept, right, at least for the value b, is going to be that 0, comma b, okay? So what does that mean, right? So, trying to find myself a nice ruler here. There we go. Okay. So, let me, yeah, move it up a little bit there. No, down a little bit. Trying to get this right. There we go. There we go. Okay. So this right here, right, is a line. Duh, right? Okay. So I'm going to start writing in some stuff here for a line. Okay. I want to draw everybody's attention to this point right here, right? This is considered 0, comma b, right? And this is what we call the y-intercept. Right? Okay. Simple enough, right? Okay. And on top of that, what we can also do is this, that we can sort of, if you take a look, right? We have a particular set of numbers here. This right here, right, is what we call the change in the x. And this right here is what we call the change in the y, right? And whenever you do the change in the y divided by the change in the x, you get the slope. Okay? That's it. That is the construction of the line, both as a function, as something that we can write down, and as its graph. Okay? All right, so without further ado, let's go ahead and have our hand at trying to figure out the equation for one of these. Yeah? Okay, so for example, right, if you need to find the equation that goes through, if you need to find the equation of a line, right, you've got to have 2 points, right, or you got to have the m and the b outright somewhere, okay? For the most part, okay, more often than not, what you're going to have is the 2 points for you to play around with, all right? And that's what I'm giving you here, okay? So what I'm giving you here is the 2 points. 5, comma 3, and negative 5, comma 1. And what I'm asking you to do is give me the equation that goes through both of these points, okay? Usually, when you have to find the equation of a line, right, there are 2 steps that you need to find. There are 2 steps that you need to go through. The first step, right, is find the slope. So you're trying to find that m value, right? And the second is find the b, find the y-intercept. Okay, and there's different ways of doing it. I'm going to show you one method. Okay, and I'm going to try to spell out each and every step. Okay, So I'm going to go ahead and do step 1 first. I'm going to try to find m. I'm going to try to find my slope first. Okay, and the way we do that is by using that equation, right? So what we have here, we have our 2 points, right? And what I'm going to do is I'm going to label each one of these. So I'm going to label this one x1, y1. Okay, I'm going to label this one x2, y2. Okay, and I'm going to roll with those. I'm going to roll with those assignments, basically. Got it? Okay, and I'm going to be using this one. I'm going to be using that one right there. Okay, so this is telling me, according to this, y2 minus y1. So my slope m has to be equal to, and is this the thinnest? Yep. Okay, is equal to 1 minus 3, because it's y2 minus y1, all over x2 minus 5 minus x1. And I'm putting parentheses to show that I'm doing, it's a 5, not a minus 5. Got it? Okay. We simplify this down, right? What we have here now is 1 minus 3, that's going to be minus 2. And then minus 5, that's going to be minus 10. So this all reduces down to 1 over 5. Okay, we're getting somewhere, right? We are getting somewhere. So now, step 2, we can already construct a couple things, right? We know that our function, right, for our line is going to be an f of x is equal to some mx plus b, okay? We just found m. So what I'm going to do is this. Erase that as well. There we go. 1/5 x plus b. We can already put in the 1/5 that we found for our slope. Okay. Now, to find the next part, right, we have to remember this, that this is always going to be equal to a y value, right? To find the missing bit for step 2, we have to find b. To find that, we can use any one of the 2 points that were given to us. We can use either this one, right, or the other one. Either one you use will get you the correct answer, assuming that you do the arithmetic right. Okay, so for this one, what I'm going to do is I'm going to use this one. I'm going to use the second point. Okay, and this is how I'm going to use it. That point gives me an x and a y value, right? Basically saying, right, this is the function, right? At least partially, completed, right? And it's got to go through one of these 2 points. I'm going to use the second one, like I said, right? Okay. Whenever x, so I'm going to do this, okay? Actually, not an equal sign. I'm going to go like that, right? 1/5. Whenever x is -5, right, plus b, I'm just going to copy that part down, right? Whenever my x value is -5, the y value has to be equal to 1. And now we get to go and solve some stuff. So if I have this, right, 1/5 times -5, that is equal to -1 plus b is equal to 1. And now I need to solve for b. B is equal to 2. We have everything we need. Our f of x function, okay, is equal to the 1/5 x plus my b, which is 2. And we are done. This is my final answer. Okay? Awesome, awesome, awesome. I'm going to go ahead and square that away too. Okay, so it says there to verify our answer, right, using a graphing utility. And that is exactly what I'm going to do. I'm going to go ahead and grab this and throw this over there. And I'm going to bring in Desmos, right? So what I'm going to do is I'm going to show you guys how to graph something on this thing, right? Okay, so we know that our f of x value is this right here, right? So I get to type this in directly, and I'm on a computer, so if you're on a cell phone or if you're on a tablet, you might need to fiddle around with the screen a little bit. but it's exactly how you think it would be. So 1/5 x, right, plus 2, okay? And I am going to, in front, put f of x equal. And I think you should get into the habit of putting in, a function name, so f of x in this case, right? But you can make it whatever you need to be, okay? All right, so here's our graph. Now, the double check would be this. This graph, this function, better have gone through these 2 points. Does that make sense? This blue line that's on the right-hand side of your screen should go through both of those ordered pairs, both of those coordinates, okay? So you can go ahead and go in there, go into Desmos, and double check really quick, right? So at -5, it should be +1, right? And if you click or put your finger on it and sort of climb it down, right, it'll give you the point, right? So there we go. At -5, it is in fact 1. And then it should go through 5, 3. So I'm going to go all the way over here to 5, and it should be 3. And look at that. Woo! We got it. Okay? So this is the way to double check that the equation that you actually found, okay, this one right here, actually is the line that you needed to find to begin with, right? You can grab the 2 points that you needed, right, that you were given, and make sure that they actually run through this line. Got it? All right. Let's keep going. Okay. Let me fix the centering here. There we go. Okay. What comes up, quick check. What comes up next is a couple quick checks that I want everybody to try. Like I said, I want you guys to do these in class. You don't have to do them, although you're more than welcome to do them at home if you want. I'm going to be doing them. I'm going to sort of require you to do them in the class. Okay. All right. So now that we know how to construct the equation of a line, and now that we know how to produce a graph for the equation of the line, right? This is one of the very first sets of functions that can be used to model sort of outside non-mathy stuff. Okay, so that's what we're going to do now. Okay, so here's the example, right? So assume a small business purchases a 2-year-old piece of used equipment, okay, and they buy it for $625. Okay, 3 years later, the equipment is worth $250. Assume that the change is constant. Okay. So first of all, what I'm going to do is I'm going to clearly define my variables for the problem that I have above, right? So you can go ahead and name them whatever you need to, right? But I'm just going to go ahead because I can, right? I'm going to call one of them X and the other one Y, okay? The X, right? If you look at the scenario, right? This thing is telling us that as the years pass, right? The value is dropping, correct? Okay, so that's exactly how I'm going to set up my X and the Y. So the X, I'm going to call that years since new, right? Because it's a used piece of equipment, right? Okay, and then the Y value is going to be the value, right, of equipment. Okay, like I said, you don't have to use X and Y. You can use any other letters, right? I would start to suggest to you all to make those letters suggestive, okay? But for now, just so that we don't get too scared, right, we're going to use X and Y. Okay, so now, using the data provided, find a linear model that describes this situation, okay? And then we're going to try to graph it. Got it? All right, so in the problem itself, we are given 4 values. It doesn't look like that we're given 4 values, but we are, okay? The first one, the first set of values is this, 2, 625. That's at 2 years, right? The used piece of equipment is $625. And notice how they're set up, right? X, Y. Okay. 3 years later, right? The equipment is worth 250. That is going to be 5, comma 250. So the 5 came from the 3 years later. So assume that you had 2 years on the piece of equipment, right? Already, and then you gave it 3 more. So that should be 5. Okay. And this is also set up as X and Y. Okay. At this point, we're off to the races, right? So I'm going to call this X1, Y1, X2, Y2. Okay. So I'm going to go ahead and just jump right in. Part 1, find B, or find M. Look at me go. Okay. So for this, right, M is going to be the Y2 minus the Y1, so 250 minus 625 all over X2 minus X1, so 5 minus 2. Okay. And I'm going to compute that really quick. 250 minus 625. That is going to be negative 375 over 5 minus 2. That is 3. 1, whoops, negative, right? Negative 125. Got it? All right. Part 2 is find B, right? Okay. So we already know that our function is going to look like f of x is equal to a negative 125x plus some value b, right? And we know this has got to be equal to some y value, right? And if you remember from the previous example, we can go ahead and grab either one of these 2 points and plug them in, okay, to find our missing b value, okay? In this case, I am going to grab the second one, okay? If you grab the first one, you're more than welcome to try it. If you grab the first one and try this out, it's still going to give you the same stuff, okay? Okay, I'm going to use the second one. I'm going to scroll down a little bit, okay? Negative 125 times 5 plus some b has to be equal to the y value for it, which is 250. Okay? So 125 times 5 is 625. Since the 125 is negative, it's going to be negative 625 plus b is equal to 250. Okay? Solving this out, b has to be equal to 875. Okay? So we're done. So if we grab this thing and this thing, we can combine them. We get this. F of x is equal to negative 125x plus 875. We're done. We're done with finding our f of x value. Okay? Now, I provide you a graph here, okay? Because I do want at one point, at least for one time, just one time, okay? Graphing it using just by hand, okay? And hopefully you guys see how this is going to work out, okay? We know that along the x-axis, the one that's horizontal, right? These are going to be the x values, okay? And these are going to be the y values, okay? At 2 years, so 1, 2, I'm going to count that to 2, 4, this is going to be 5 years, right? The amount of money should be, that it costs, it should be 250, right? So we do need to stipulate, and I need to move some stuff around. This is a bit too close to my graph, so I'm going to move it away. Just enough so that I can still write some stuff in. Whoa, not what I wanted. Give me the pen. No. There we go. All right. So what I'm going to do now is I'm going to divvy up the y-axis to give some sort of a nice little count. Okay. So we need to get up to 875 on the y-axis somehow, right? Okay. And the way I'm going to do that is this. Every one tick mark, 1, 2, 3, 4, 5. I'm going to make this $500. Okay, so then that means 6, 7, 8, 9. The very top end here is going to be $900. Whoops, not a circle, dollars. Okay, hopefully you guys see how this is going to go down, right? We have 2 points here, 5 and 250. So that means at 5 years, right, it should be 100, 250. It should be, I'm going to go ahead and do it in blue. That should be a point, right? And then the other point at 2 years, it should be 625. So 1, 2 years, 6, so 5, 625. Whoa, why did I do that for? Not what I wanted. There we go. Okay. And at this point, it's connect the dots, right? Hopefully you guys see what's going to happen. Don't judge me. Don't judge me. Please don't judge me. Ah, there we go. That's as close as I'm going to get it, I think. Okay. So this right here is my f of x is equal to negative 125 x plus 875. This is the graph for our function. Okay? Now, like I said, this is the one time that I kind of want you guys to produce something by hand, right? And I think I've mentioned in class before, I'm going to forego the rest of graphing by hand so that you guys can be allowed to use Desmos to graph, okay? So that's what I want to do now. I'm going to go ahead and there's some extra stuff that I want to show you to show everybody, right? We know what our function is, right? So I'm going to go ahead and type that in. 125 x plus 875. Okay, now it doesn't look the same. Okay, I'm going to say f of x up front equal, and it needs to be negative. Can't forget that. Okay, so notice what I typed in, right? Okay, but our screen doesn't show it. So make sure when you do use Desmos for this kind of stuff, right, that you zoom in and zoom out to make the graph show up nicely. Okay, so I'm going to zoom out real far. Oh, there it is. Didn't have to zoom out too far. But it still doesn't look like ours, right? So what I want to show you, right, if you're on a cell phone, this is going to be super simple. Okay, if you're on a tablet, something that has a keyboard, this is where it become. I need to show you this before you go crazy trying to zoom in. Okay, if you hold down the Shift key, so I'm switching back and forth between the Shift key and not the Shift key. Oh, not what I wanted to do. You see that my cursor changes, right? You can zoom in and zoom out based on that axis. So look what happens if I drag my mouse. It shrinks the x-axis, or the y-axis in particular, right? But it leaves the x-axis alone. And now we have the graph that we need. Okay, and you can do the same thing for the x-axis as well, see? Okay, but now we have the graph, which is great. Okay, the next part of our problem, and I'm actually going to keep this up here, okay, is I want you guys to all fill out the table that's provided, okay? And I want to show you guys how to do that using Desmos. Desmos actually does this for you, right? So the x variable, we know this was time since new, right? S-I-N-C-E. And then y, right, was equipment value, right? Okay. So what I want to show you all is how to get these values, right, using Desmos. Now, if you grab your equation, right, if you grab your equation and just go ahead and type in 0, 2, 4, 6, 8. I think I made you guys go to 10, 12, okay? You'll get the answer, okay? But I'm going to go ahead and show you guys something so that you can forego doing those calculations. Desmos can actually do it for you, okay? So what I'm going to do is I'm going to go up here into Desmos, and I'm currently in Desmos, and I'm going to go ahead and add a table. Okay, and in this table, what I'm going to do is I'm going to get rid of that. I'm just going to call that X, and my Y values, I'm going to delete that, and I'm going to make them F of X. Okay, and what this does now is because we defined an F function, which is the equation for our scenario here, right? We can go ahead and put in X values to our heart's content, and this thing will calculate it for us. So for example, 0 gives me 875. 2, 4, 6, 8, 10, 12. Okay, so that is it. This is going to be, whoa, wrong pen. 875, 625, 4 is going to be 375. Moving right along, 6 is going to be 125, 8, negative 125, 10, negative 375, and then 12 is going to be negative 625. Okay? Okay. Moving right along, let me center this again. Bam. Okay. I want to use the model that we found in B. So I want to use that equation that's in the green, that's in green right there, right? I want to use it to try to find the value when it's 5.5 years old. We know how much it's going to cost at 5 years exactly, right? That, according to our thing, is supposed to be $250. Yeah? Okay. But I want to do it when the age of the equipment is 5.5. Okay. It's exactly what you think. That this means grab the 5.5 and put it into our X value. So this is going to be F of 5.5, negative 125, 5.5 plus 875. And again, I think I've mentioned this multiple times, right? Desmos is a good calculator in its own right. So I can grab this and throw this in here and get myself a value. So negative 125 times 5.5, right? Plus 875. So this answer should be 187.5. Okay? Okay. Let's move on. E. When will the piece of equipment have no value? So we know that the equipment is modeled by this, right? The equation is f of x is equal to negative 125x plus 875, right? In terms of our scenario, if the equipment has no value, right, then that means that the y portion, right, this equation itself must equal 0 if it has no value, right? So we are going to solve out this piece right here, this right there, okay? So in order to do so, right, minus 875, minus 875, I'm going to move over here. Minus 125 is equal to minus 125x is equal to minus 875, right? And I have a multiplication here. In order to get rid of the multiplication, I need to divide. So divide by negative 125 divided by negative 125. X is equal to, okay, again, I'm going to go to Desmos. Desmos is awesome, I swear to you. Negative 875 divided by negative 125. Oh, let me actually put it how it's written. So I'm going to put the negative up there. There we go. X equals 7. So what did we just do? We found when the equipment will have no value. According to this, right? According to this, the equipment will have no value after 7 years. Got it? All right. So now, the more important bits, I mean, all of this is important, right? But the more important bits that I want to really cover is this, the interpretation. So a fair amount of the stuff that we are going to be covering is going to be real heavy on interpretation, grabbing the mathy stuff and turning it into plain old good old English. Okay? Okay, so what I'm going to do here is this. I'm going to write our equation over here really quick. The f of x is negative 125x plus 875, right? So this was the equation that we found, right? What I want to do now is I want to interpret the two parts, the y-intercept and the slope, right? And we remember, right? This is the slope, and this right here is the y-intercept. Okay, so I want to turn both of these numbers, whatever they mean, into plain old English. Okay, so our y-intercept is this, right? 0, comma 875, because that's the tail end right here, right? Okay, this automatically tells us what it means. So the x is 0, the y is 875. Our x value stood for the number of years since new, right? And then the y value gave us the value, right? So this automatically gives us everything we need, right? So brand new, right? The equipment costs $875. That is it. Boom. Okay. Last one. Okay. This one tends to be a little, there's a little bit of stuff that we need to do beforehand, right? So we know what the slope is. Our m, right, is going to be negative 125. Well, let me just write it normal. Negative 125, right? This, I can also write it like this, negative 125 over 1, okay? Now, if you remember the definition of the slope, this is considered a change in y divided by a change in x. And I'm going to interpret it exactly that way. These two are going to be something, and these two are going to mean something. Okay? So usually you go from the bottom when you explain this, right? You describe the x first, right? And then you reference the y, okay? So let me go ahead and just give you guys the solution here. Every year, the value drops by 125, okay? The every year is the yellow bit, right, from the bottom, right? And then the Blue is given by that. Okay, notice where we're getting that from. That is here. Okay. Woo. Okay. What I got coming up now, right after this, I've got a couple quick checks for you to try out. Okay. Uh, the questions are going to be the same for both, and I want everybody to try them out. The odds do this one, the evens do this one. Like I said, we'll try these out in class, and we'll cover them both to make sure everybody gets them, everybody gets their examples, okay? The last thing that I got to do is cover how to find X and Y intercepts, or what they look like, right? Okay. For x-intercepts, what to do here, right, is when the function touches or crosses the x-axis. Okay. And to do that, to find this, right, you set y equal to 0 and you solve for x. Okay. For the y-intercept, it's actually reversed. You set x equal to 0 and solve for y. This ends up being really important in the future when we are not messing just with lines. We're going to be messing with stuff that has lots and lots of curves in it, okay? But this is the usual way. This is the way that we find any x-intercept and any y-intercept, okay? All right. I think that is it. Comes up next is lecture questions. If you have any questions on the stuff that I just covered, ask me during our quick check time. Come down to my office hours, and if you can find me in the math lab, ask me then. Cool? Besides that, happy studying.